All right, hello everybody. This is Gridius, and this is a lesson about simplifying radicals. Okay, so if we look at our I can statement, it says I can simplify radical expressions that are not perfect square roots by finding the square roots of their factors. So a radical, just so we know, is this symbol right here. This symbol right here is a radical. That's what it's called. And really, what this means is the square root. So when we're talking about the square root, if we're talking about the square root of 9 right here, what I'm asking, just a quick little review, what we're trying to find out is what times itself equals 9. So what number, if I multiply it by itself, will it equal 9? And that's what square root means, what number times itself. Well, the square root of 9, if we know that 3 times 3 equals 9. So therefore, the square root of 9 is just equal to 3. That's my final answer. Okay, so the problem is what happens if we have a square root or a radical that doesn't have a perfect square underneath. So the square root of 9 was easy because if we know our multiplication facts, we know that 3 times 3 is 9. So the answer is just 3. Well, for 12, I know that 3 times 3 is 9. And if I go to the next number, 4 times 4 is 16. So that means that the square root of 12 is somewhere in between 3 and 4. So there is no exact answer. It's going to be a decimal. So what we want to do is we are going to simplify this into its simplest form, and there's still probably going to be a radical involved. So what I want to do is I want to separate 12 into two factors. And when I separate into factors, I want to separate it into factors hopefully with one being a perfect square. So here's what I mean by that. If I know that the square root of 12, I need to figure out what are factors of 12. What times what equals 12? And the first thing that pops into my mind is I know that 4 times 3 is equal to 12. So this is a square root. All I did is I took this 12 right here, and I just expanded it out just a little bit, found two factors of it, 4 times 3. So this is the same thing as 12. So now what I'm looking for is the reason why I separated to 4 times 3 is one of these numbers is a perfect square, and I can actually simplify that outside of the radical. If we take a look, 4 is a perfect square. So really what's happening is this is kind of like the square root of 4. It's the same thing as the square root of 4 times the square root of 3. Once we have multiplication underneath the radical symbol, we can actually split it up into two separate pieces. So the square root of 4 times 3 is the same thing as the square root of 4 times 3. Well, now the square root of 4, I can actually simplify this because the square root of 4 is 2. The square root of 3, I cannot simplify this. So the square root of 12 is equal to 2 times the square root of 3. And I'm done. One thing I want you to notice how I did not put a multiplication symbol in between. We don't need that. Okay, it's kind of like when we attach a variable to a coefficient. Okay, we just attach the 2 next to the root sign. This means right here 2 times the square root of 3. Let's look at some more. So again, to simplify a radical that is not a perfect square, we want to find factors of the number and then find the square root of the factors. So we're really trying to separate this into find the factors that are a perfect square and then pull that square root out of it. So we have the square root of 18. So we got to think of what factors go into 18. And the first two that come to my mind is the square root of 9 times 2. Okay, because 9 times 2 is 18. So now that I know that 9 times 2 is 18, I was fortunate enough right here where 9 is a perfect square. So I can find what the square root of 9 is and bring that outside. So again, it's set up just like the square root of 9. Whoops, I got ahead of myself. The square root of 9 times the square root of 2. Now I can simplify it. The square root of 9 is 3. And I can't go any further down with square root of 2. So I'm just going to leave it as 3 root 2. So 3 times the square root of 2. Let's try another one here I'll do this one in red. So let's try one here with the number 40. So the square root of 40, I need to separate. I'm trying to find a perfect square for the factors. So right away, I know 4 times 10 is one of my factors. I know I could do 20 times 2, 4 times 10. There's a lot of factors that go into 40. But if I do 4 times 10, the reason why I like 4 times 10 a lot is it gives me a perfect square right here. I know that the square root of 4 is 2. So when I separate it into 4 times 10, this is the square root of 4 times the square root of 10. Square root of 4, let's go down here. This is just 2, and I still have my root 10. Now I need to ask myself, I need to make sure, can I simplify the square root of 10 anymore? And the answer is no, because the only factors of 10 are 2 and 5, and none of those are perfect squares. So I can just go ahead and leave this as 10. So my answer is 2 times the square root of 10. So the same exact rules are going to apply for variables. Okay, it might look a little confusing at first for variables, but it's really no different. So if I were to look for the square root of x, that means what number times itself equals x? And I want to see, can I just simplify this any further? And the answer is no. I cannot simplify this anymore. Because x, I don't know what number times itself equals x, because I don't know what x is. So the square root of x is just equal to the square root of x, because I don't know what factors x has. But what if I have x squared here? If I have the square root of x squared, I can separate x squared into some multiplication, because x squared is just x times x. So if I'm asking myself, what number times itself equals x multiplied by itself? So what happens is the square root of x squared actually cancels out this square, and it just becomes x. It's kind of like going backwards, because we also know that if I were to take, say I had x squared equals 16. Real quick, let's do a quick review of an equation. X squared equals 16. I want to know what could possibly be x. So what number times itself equals 16? Well, what would cancel out my exponent is I would take the square root. That would cancel out the exponent and get x by itself. And I would take the square root of 16 to get x equals plus or minus 4, because the square root of 16 is positive or negative 4. Very, very similar here. So now we're just going backwards. If we have the square root of x squared, it cancels out this exponent, this squared, and it makes it just into x. So if I had x to the third power, okay, so that means I have x times x times x. Okay, well, if x times x is the square root of x times x squared is just x, what that means is I can pull this outside, okay, because the square root of x times x is x. And then I still have 1 left over in my radical. So I have x on the outside times the square root of x still. So x to the third power simplifies to x times the square root of x. Because by having x squared, I can pull out an x squared, because the square root of x squared is just x. So when I pull out my square root of x squared right here, that's going to give me my x on the outside, but I'm still left with this last one on the inside, which is why I still have the square root of x times whatever the square root of x squared was, which is just x. It's a little confusing. Let's look at some examples with some numbers to see if that can help out. So I have the square root of 9x cubed. So this is very simple. This is the same thing as the square root of 9. I can separate out my terms if I want, times the square root of x to the third power. Square root of 9, that's easy. That's actually a perfect square. We don't have too much work to do with that. That's just 3. So now I have 3 times the square root of x to the third. Now I got to figure out, can I pull out any perfect squares from x to the third power? I can pull out an x squared, okay, because this is the same thing as 3 times x squared times x. And we know that x squared, if I were to take the square root of x to the second power, it's just going to be x. So that's going to bring an x to the outside times the square root of x times 3. So I have 3 times x times the square root of x is my final answer. So 3 times x times the square root of x. Let's look at another one. I have the square root of 32 m to the 5th. So let's separate it out into my 2 terms so we can work one piece at a time. So I have the square root of 32 times, and I also have the square root of m to the 5th power. Well, first, let's work on the square root of 32. Okay, so the square root of 32, I want to figure out what factors it has. So right away, I know 8 times 4 is equal to 32. So I could separate this out into square root of 8 times 4. Now, I have a perfect square here that's going to bring it out, but I can break down 8 even further to another 4 and another 2. So what I want to do is see if there's maybe a greater factor that might make this a little bit less work for me. And the other factors we could use would be the square root of 16 times the square root of 2. 16 times 2 is 32, and 16 is a perfect square. So what I can do is the square root of 16 is just 4. So I have 4 times the square root of 2. Next, what I have is I have the square root of m to the 5th power. Okay, so if I'm trying to find the square root of m to the 5th power, I need to ask myself, well, what do I have inside of here? So that's the same thing as the square root of m times m times m times m times m. And if we remember, we can pull out, if we want to pull out a perfect square, we can pull out 2. So these two, this would be like m squared. This would be m squared. So I can pull out the square root of these two m's is just m. The square root of these two m's is also m. So really, I'm pulling out 2 m's. I'm pulling out the square root of all 4 of these m's is actually m squared. Because this would be m to the 1st power if I take this out, and this would be m to the 2nd power if I take the second one out. So that'd be m squared times m. Now I need to combine these two terms. 4 times the square root of 2 times m squared times the square root of m. So that would be 4m squared, just keep my outside terms together, times 2m. And that is all the way simplified. I'm all done. So what I did is I just took my outside terms, I just combined it, okay, and I put both of my terms inside the radical, and that's it. Okay, that's all I have for you guys. Okay, if you have any questions, please do not hesitate to email me, leave comments in the YouTube channel, or ask me in class. Okay, and I hope this video helped. Go get some practice problems done, and good luck to you guys.